Effects of heat. Metals, due to their strength, are widely used in the construction of many devices, instruments, machines, big structures, etc. Since the metals expand on heating, special care is taken in designing them. The expansion property of metals are used in a number of instances. Some of the important practical applications of thermal expansion of solids are the following: railway tracks, riveting, metal tires on wooden wheels, pendulum of a clock, mercury compensated pendulum, Harrison's grid iron pendulum, bimetallic strip, balance wheel, bimetallic thermometer, thermostat. Railway tracks. Rail segments made of steel expand and contract during large temperature variations. Small gaps are left between adjacent rail segments to allow for free expansion during summer. If these gaps are not provided, the railway lines may bend sideways due to the forces developed during expansion of rail segments. Riveting. Riveting is the method of joining metal plates using small cylindrical steel rods called rivets. Rivets are heated to red-hot condition, thereby expanding it and slipped through the holes drilled in the plates. The ends of the rivets are flattened by hammering. When cooled, the forces developed due to contraction holds the metal pieces firmly together. Metal tires on wooden wheels. Wooden cartwheels are fitted with iron tires. The iron tires selected are slightly small in diameter than the wheels. When tires are heated to red-hot condition, they expand and can easily be slipped over the wheels. On cooling, the iron tires contract and hold the wheels firmly. Pendulum of a clock. Pendulum of a clock is made of a metal. The length of the pendulum increases in summer due to expansion. As a result, the time taken for each oscillation increases and the clock loses time. That is, the clock grows slow. The length of the pendulum decreases in winter and the clock gains time. That is, goes fast. In an ideal pendulum clock, this loss or gain in time is avoided by using a compensated pendulum. This type of pendulum is compensated against the effect of expansion or contraction due to change in temperature. Mercury compensated pendulum and Harrison's grid iron pendulum are two types of compensated pendulum. Mercury compensated pendulum. It was invented by George Graham. When the atmospheric temperature increases, the length of the iron rod increases downwards, which tends to lower the center of gravity of the pendulum. But mercury expands and tends to raise the center of gravity of the pendulum. In effect, center of gravity of the pendulum remains unchanged, keeping the effective length of the pendulum constant and showing the right time always. Harrison's grid iron pendulum. This pendulum consists of 5 iron bars and 4 brass bars connected to each other. Iron bars have free movement in downward direction and the brass bars have free movement in upward direction. The ratio of the lengths of the iron bars to the brass bars is 3:2 since coefficients of linear expansion of iron and brass are in the ratio 2:3. This ensures that for every 1 degree Celsius rise or fall in temperature, the expansion of iron is counterbalanced with that of brass. Thus, the effective length of pendulum as a whole remains the same and the clock gives correct time. Bimetallic strip. 2 equal flat strips of different metals, example, brass and invar or iron, which are riveted together at different points along their length to form a bimetallic strip. Brass, low coefficient of linear expansion. Invar, high coefficient of linear expansion. On heating or cooling, the metal having high coefficient of linear expansion expands or contracts more, respectively. Balance wheel. It is used to regulate time in watches. The regulation of time of a watch depends on the period of oscillation of the wheel, which in turn depends on its diameter. The seasonal temperature changes will increase in the wheel diameter, gain time, or decrease in the wheel diameter, lose time, thereby changing time. To compensate for the change in diameter, the rim of the wheel is made of a bimetallic strip with brass on the outer side and iron or invar on the inner side. The strip is divided into two equal parts, and they are joined to the center by a rod called spoke. Bimetallic thermometer. It consists of a thin bimetallic spiral coil. Its one end is clamped and other free end is attached to the spindle of a pointer. The pointer moves over a scale graduated in degrees. As the temperature rises, the bimetallic strip tends to curl in a clockwise direction, and the pointer moves on the graduated scale. Larger the increase in temperature, greater is the bending of the strip, and so more is the deflection of the pointer. Thermostat. It is a device used for maintaining a steady temperature. Its working is based on the behavior of bimetallic strip with the change of temperature. Other examples of thermal expansion. Small spaces are left behind the walls while mounting girders so as to allow for expansion and contraction. The wires in the overhead power transmission line are kept loose so that they may not break when they contract in winter. In kitchen, instead of ordinary glassware, Pyrex glassware is used because the coefficient of linear expansion of Pyrex glass is very low. Thick glass jar cracks when hot water is poured into it. The reason is that the surface of glass in contact with hot water expands while outer surface remains cold, since the glass is a poor conductor of heat. Due to this unequal expansion, the jar cracks. The end bars of a steel bridge are not firmly built into the pillars of brick or concrete on which they rest, but are supported on rollers which allow them to expand or contract without affecting the pillars. It is far easier to fuse a platinum wire in glass as compared to a copper wire, because coefficients of expansion of glass and platinum are almost equal, but not so with glass and copper.